All right, we're going to continue with kinematics examples. There are two harder problems we're going to go through. Stay with me. I'm going to try to get it done under 12 minutes. All right. Question number one. A medical helicopter is ascending with a speed of 8 meters per second at a height of 120 meters above the earth. While the helicopter is still ascending, a medical package is dropped from its window. How much time does it take for the package to reach the ground? All right, so here is the situation that we have. Let's try to what we do know. We do know a few things, but one thing that we have to be careful with. What is the initial velocity? Well, the initial velocity of that package, the package inside the helicopter is moving upward. So that is 8 meters per second. Okay. Now, the distance or displacement, D, is 120 meters above. Now, when it says above, you have to be aware that it's actually negative 120 meters from where it's supposed to be. Okay. So, and then the acceleration, which is G, that is negative 9.8 meters per second squared. And the V final hitting the ground, that would be 0 meters per second. Okay. And we also don't have the time, but we do have other variable to use and solve. We're going to use this formula. The displacement is equal to V initial t plus 1 half gt squared. And we're going to use this formula to solve for t. Okay, so we're going to plug numbers in. What do we have? We have negative 20, it's negative 120 meters, equals to initial velocity 8 meters per second times t plus 1 half negative 9.8 meters per second squared times t squared. You notice that we have this equation that is quadratic. Okay, that's what that is. We have a quadratic equation that we need to solve. And at this point, I'm assuming that you can solve a quadratic equation. When you do the math in here, you'll end up getting negative 120. I'm going to remove those units for now until we finish with the math. This would be 8t minus 4.9 t squared. When you bring everything together, if you want to set it up, multiply everything and bring everything together, you solve this equation as 4.9 t squared minus 8t minus 120, set that equal to 0. In here, you have to use quadratic formula. And for quadratic formula, if you don't remember, I'm going to put a link to a card about using quadratic formula, but the formula is given by this minus b plus or minus the square root of b squared minus 4ac all over 2a. This is for the grade 11 or algebra 1 math that you should be able to do. And since it's a prerequisite for physics, introductory physics, to have the at least initial math 11 coming from this equation, quadratic ax squared plus bx plus c is equal to 0. And a, b, c, it's in the formula. You just plug numbers in and we have that. In here we have a is equal to 4.9, b is equal to negative 8, c is equal to negative 120. When you plug numbers in there, you'll end up getting this setup. You get t1 comma 2. Remember, the equation is t now. All right, this is the t variable, not the x variable. And what you will get is 8 plus or minus the square root of b squared, which is 64, and then minus negative minus 4ac, 4 times 4.9 times negative 120 all over 2a, and that is 9.8. That is 2 times 4.9. Okay, when you do the math, everything is said and done. When you do the math, you will get T1 2 equals to 8 plus or minus 49.15 divided by 9.8, but then you can't take the negative value, this negative value, that means 8 minus 49.15 divided by 9.8. You can't accept that because the value on that one is negative. We don't have negative time. So you have to take the positive only. And then you just use the positive. You get T2 equals to 8.49.15 divided by 9.8. And in here, you get approximately 5.83 seconds. Okay? That's how you do this question. This is why this question is a little bit more involved, because you have to use quadratic formula. Okay? So make sure you know how to do this. Go through it again. All right, let's do another question. But again, before doing that, I feel compelled to make sure that you do not make a mistake. And this is the common mistake right here. The initial velocity is 8 meters per second. A lot of students think that at that 120 meters above the ground, when you're releasing a package from the helicopter, even though helicopter is ascending, right? The helicopter is still ascending, it's moving. Is think of this package is actually moving up, right? So here it is. I'm releasing this package right there, but the package is still gonna move up at 8 meters per second before, so moves up again a little while for a fraction of a second before the gravity will pulls it down. G, which is negative 9.8 meters per second squared, pulls it down. But within that fraction of a second, the still is going up. Okay, so it could be from 120 meters goes up to 122 meters, which is we just don't know. But when you have to accept that the package is moving up, the initial velocity is 8 meters per second, just like the velocity of the ascending velocity of the helicopter. Okay, question. A bullet is fired straight up from the ground level at the velocity 182 meters per second. And then we need to go ahead and answer 3 or 4 parts of that question. The first one is, how high does the bullet go? I wrote down all the information that is given to us: the initial velocity, the acceleration due to gravity, negative 9.8 meters per second squared, and V final. In here, V final is 0 meters per second, because at the top, the final velocity will be 0, and then we want the height or the displacement. Out of all the five formulas that we have, the only one that actually makes sense to use will be this one right there. Okay, the V final squared equal to VI squared plus 2AD, and then we're going to go and solve for D. Now, we get 0 meters per second squared equals to VI squared, the initial velocity, 182 meters per second, all of that squared, plus 2 times negative 9.8 meters per second squared, and then times D. And then we're going to solve for D. We're subtracting that. We're isolating this area right there. And that would be negative 19.6 meters per second squared D. Divide both sides by negative 19.6 meters per second squared. And negative 19.6 meters per second squared. D is, we'll get the distance or the height will be 1,690 meters. So about 1.7 kilometers into the sky. That's how high the bullet will go. Okay, so that is the answer to the first question. Let's look at the second question. How long does it take for the bullet to stop? So V final is, now in here, when we say a stop, there are 2 times that the bullet will stop. One at the top of the trajectory when he hits the maximum height. The other one is at the bottom when he goes hit the ground again. Okay, so at both times, bullet will stop. So let's look at the top piece, and that's what we're going to talk about first. So V final is 0. That's equal to V initial 182 meters per second plus negative 9.8 meters per second squared, and then multiply by T. And then we do the math, negative 182 meters per second. We're just isolating, and that's negative 9.8 meters per second squared times T, and divide both sides by negative 9.8 meters per second squared. And we can get t will be equal to was 18.57 seconds that will reach that height and the bullet will stop. Okay, that's the first one, but there is a second one, and then we're going to get to that as well. So this is the t at the top, and now let's look at part C. Now, what's the bullet's total time in the air? Well, if it's going up and it took 18.57 seconds to go up, t at the top is equal to t from the top to bottom, which is 18.57 seconds. So coming down, t down will end up being the same. It will take same amount of time to come down. So you just have to add them. Okay, when you add these two, you'll get 37.10 seconds. That's the total air time for the bullet going up and coming down. Remember, that's the trajectory is happening. Now, the last thing, there is a tricky question that I'm asking. When is the bullet's acceleration equal to 0 in this example? And I'm being tricky here. Bullet's acceleration is 0. Do we have such a thing? Well, what do you think? Bullet is going up at the very top, momentarily stops, and then comes down. The question is, at any time in that path, will the acceleration will be 0? Well, the answer is never. No. Acceleration, which is g, which is negative 9.8 meters per second squared, is always there. It's always working on that object at all times. Okay, so it works on the object, on the bullet, all the time. Okay, so there is no time that the acceleration is 0. Okay, that's very good. I hope you found this useful. Check out the quiz and make sure you continue with the series. Until next time.